Dear students, let us start with Unit 4 which is telling us how we can improve efficiency of our information retrieval system. Till now we have seen how I can represent a document using the different representation techniques. Then how I can find out the similarity between the document and the query. Then we have seen how the meaning is affecting my retrieval process in Unit 3. Now Unit 4 wants to improve the efficiency of our information retrieval system. Now here you should remember that efficiency of information retrieval system is whole and soul depending on memory. If I am able to utilize my available memory in a efficient way, then only that mapping will be in an efficient way and the fetching will be efficient way, and which will improve the relevance of my retrieved data. Okay, so in Unit 4 we are starting with the indexing structure that is known as a inverted index. Now what is there in inverted index? Each term T, okay, we must store list of all the documents that are containing T. Means there will be a particular term T and there will be any number of documents which are containing that term T. Then I want to store the list of it. Means in a table I want to map the term with the document. Okay. Now each document is identified by a ID. That ID is called as a document ID. Now that is what the document serial number. Okay. Now here question comes to our mind, can we use a fixed size array for this representation? Okay, I want to store a list. List means what? It is an array. Now will this array will be of fixed size or variable size? How we are going to store? Here I am having three terms, Brutus, Caesar and Calpurnia. This is the list of the documents in which this term is present. Okay, and you can see the serial numbers, that is the document IDs. Okay, now you can see the list is variable based on the existence of that term in a particular document. Now the question comes to our mind that what happens if the word Caesar is added to the document 14? Okay, Caesar word is added to the document 14. Now 14 should be the part of this list. As 14 is not already existing, so I should add 14 there. But here what is happening? My list is full. Now that's why whether your array is fixed size or variable size, that you should first decide if you want a proper representation. Now here we need variable size posting list. But what do you mean by posting? Whatever is your representation, whatever is your index, that index is called as a posting. Now we are having a continuous run of the posting and it should be normal and best. And now for array, if we go for the variable size, then every time we have to redefine the size of the array. That's why the best option is use either linked list or use a variable length array, because I know that whatever is the size of my list, if it is predefined and if it is full, and when I want to add a new document ID in it, it will not work. Okay, I will lose that data during the retrieval process. I don't want that loss. That's why use either linked list or the variable length array. Okay. Now here you should know that these document IDs are in sorted order for easy retrieval. Okay. So that is known as a posting, and the collection of your terms is known as a dictionary. Remember these two words. These words we are going to use frequently in upcoming videos. Dictionary means what? Set of your terms. Posting means what? Whatever is a entry in your list, that entry is called as posting. Now, and the set of those all entries, that your whole list is called as postings. Now, yeah, as I told you, you should notice the document IDs, those are sorted order. Now, what are the steps in your inverted index construction? first you will have a collection of the documents that you want to index. Okay, and these are the terms based on which I am going to perform the indexing. Now the next process will be what? Tokenizer. Divide the terms and get the tokens. So what tokens I am getting? Friends, Romans and countrymen. Okay, this is what the stream of the token. Next, linguistic models means in a day-to-day language, how you are using these terms, friend, Roman and countryman, like that. Means you should be able to capture all the possible combinations of that term. Then only there will be a proper match. Then only there will be a proper retrieval process. Now, what we are doing? Finally, we are going for the indexing. So, these terms are part of these documents. So, those documents IDs I am representing using a linked list. Now, in initial stage of the text processing, the first step is what? Tokenization. Means you have to divide whatever is your string, that string should be divided. Then normalization. Normalization means what? All the forms I don't want. Everything I want in a same format. Now USA and USA both are pronounced the same, but I am not pronouncing it as a U.S.A. Simply I will pronounce it as a USA. So that conversion you will do in normalization process. You will bring everything to a same form, okay, without using any special character. Now the next one is what? Steaming. So the different forms of your root you want to match. Where the term root has been come, we have seen in the past tree. We are developing the past tree or the dependency tree. So there the term root will come. Now authorize, authorization, all its variations you should remove by the stemming process. Okay, and then the stop words, the more commonly used words which will have more frequency, but it is not helpful for my retrieval process. So that is what called as a stop words, and you may remove those stop words if you want to save memory in your index, as well as it is not affecting your retrieval process, you can remove it. So here let us see with the example. Okay, now this is my document 1 which is containing more number of the terms, and this is the document 2, again it is containing more number of terms. So in document 1 you can see that 1, 2, 3, 4, 8, 11 and 14 terms are existing there. So I am occupying first 14 rows with the document ID as 1. The step-by-step process for inverted index formation that I am starting. Okay, these are two documents and these are the terms inside the document. There are 14 terms in document 1. So it will occupy 14 rows of my table. In the same way, the next rows will be occupied for each and every term of document 2. This is the first step. Next step. Then simply in the first step, you will develop a table in which there will be term and there will be doc ID. Now, question comes to our mind that Caesar is a word which is existing in document 1 as well as document 2. Then why I am using 2 rows for the same term? Why I am not taking into account the frequency of term while representing it using index? In the next step, we are going to see that one. Now, what I am doing here, I want to sort the terms. Now, you can see here that my first term is starting from I, but it is not alphabetically sorted. So, the terms will be sorted alphabetically. Your whole table will be sorted alphabetically, and the corresponding document IDs are also shuffled, means the sorting is expanded. Now, the next thing, here you can see very clearly. Okay. Now, as I told you that there are some terms which will appear twice, that is our Caesar term. Okay, it is appearing twice. Even the Brutus term, that is appearing twice. Then in that case, you are changing the index accordingly. You are not repeating the data. So here the term and the document frequency you are noting, and you can check that if the frequency is 1, then that is represented by only one node in the posting, but when the frequency is 2, then it is represented by 2 nodes of the posting. Okay. Now just check it out. One more word with the frequency 2 is the, and the one more is was, but actually the and was are what? Stop words. It is not improving the efficiency of my retrieval process. Now, so this is what your proper indexing, in which you should represent the term followed by the document frequency and then the posting list. And when the document frequency is 2, give the 2 nodes in your posting. Now, this is the final one. Okay. Now, this is what the term and the count, and on the right side you can see the pointers and then the list of the document IDs. Okay. Now, in IR system implementation, means in information retrieval process, how do we index efficiently and how much storage I will use? So, how much megabytes of memory I need, that we should be able to find out. So, what are the advantages of this inverted index? It will allow me a fast searching. Okay. The process is giving me more cost, but the searching is fast. Now, why it is more cost? Because you have to store the index using that much amount of the memory. It is easy to develop and it is a popular data structure. Okay, most of the search engines uses inverted index as a data structure. Now, what is the disadvantage? Yes, high maintenance cost. Means when I am changing even a one document, when I am removing even a one document, when I am adding even one more term, then in that case everything I have to update. Okay, adding one more row in that table is really costly, and what they are saying is retrieving data in the decreasing order of expected usefulness. The records are retrieved in the order in which they occur in the inverted list. Yeah, everything is depending on your table. In that order only there will be the retrieval. Now, these are the features, means you can say that the most applications, that is the efficient search, fast update, flexibility. Then you should apply the compression technique that we are going to see in upcoming video, and there is a support for steaming process as well as a synonym expansion and support for multilingual search. That is what whatever is the language variation, that is handled by this inverted index. So, this is all about the inverted index. Thank you.